Having me here. If you do the technical stuff, I can just start with a small introduction and everything. Yeah, quite fine. So, hello everyone. My name is Captain Lieutenant Dr. Sascha Hartig. I'm the coordinator additive manufacturing in the German Navy. When I'm using additive manufacturing or 3D printing, it's like it feels like being Santa Claus on Christmas Eve. You're giving back the people, the soldiers, the sparkling in the eyes, because for the first time, like it feels like centuries, you have a possibility to resolve a problem you have, which you couldn't solve with the tools you have. Additive manufacturing is now, when I take it on board with me, with the soldiers, one solution we can use to have things fixed in between of hours, sometimes days when it's more complicated, but we can do something which doesn't take as long as 1 year, for instance. And this is what is additive manufacturing for me. But if you're looking like now 1 year after we implemented additive manufacturing, perfect. It's also, you have to consider, it's on the first days, it's like the sparkling in the eyes. But what is coming afterwards? And this is also all about my presentation. What are the lessons learned? What did we do? And what did we learn from that? So, in the beginning, my name, I said it. My topics in the Navy are integration of additive manufacturing in the German Navy, creating an international standard for integrating of advanced manufacturing onto temporary self-sufficient systems, like ships, oil rigs, something like that, and additive manufacturing as an innovation driver for the military environment. But how does it look like if we take a printer with us on board? I have some videos from research we did some years ago. And it looks like, hopefully it works, this.
3D-Drucker. Mit ihm wird auf hoher See
I take it without the German voices. So we took a 3D printer with us on board and we used it for some small interim parts. So just like small things that change everything. Because the worst thing that could have happened is we're doing a 2 weeks tour. And after the first week, we think, oh, where's the problem with a part? And we have to cancel the tour and go back to the harbor. But with additive manufacturing, we can produce this part. And after this 2 weeks tour, we can finish the tour and change back to the original part if it's needed. So additive manufacturing for these parts, for instances, help us to keep the ship in a high state of readiness. So we want to use additive manufacturing for spare parts in a common sense of interim parts. So the problem is that we don't have the spare part available. And we don't want to cancel the tour, as I told you. We use additive manufacturing for producing interim parts. So parts that just are in the place for like 1 week or 2 weeks, or how long it takes to get things done, to get our mission completed. But we want also to use additive manufacturing for prototypes and also new product ideas. And this is where the sparkling in the eyes comes back to the soldiers. This is where you can imagine new products, new things, something you want to change in your daily business, and you can make a first prototype. Afterwards, of course, you have to bring these ideas also into the process to get a technical change and all the bureaucracy. But you have the first time, you have giving back the soldiers the possibility to develop something. But we have some hurdles to overcome if we are implementing additive manufacturing. The main problem is we have on the one side the experts of additive manufacturing. I think most of you are the experts I'm addressing here at the moment. We have the knowledge for what is fused filament fabrication, selective laser melting, laser beam melting. Every expert knowledge you need to implement additive manufacturing. But on the other hand side, you got a lot of people in your company which are in the procurement, which are not known to additive manufacturing. And we are using we have two terms for additive manufacturing. It's 3D printing, and we use it in two ways. The one way is it's just a plastic printer, doesn't make anything that is really of worth. And the other thing is like it's a 3D printing. It's a wand. You can do anything with it. And the truth is somewhere in between. But we need something to communicate also in a company with these people which don't know additive manufacturing with the smallest particle of the process. So we have the problem that on the one side we have the AM processes, and on the other hand side we have the use cases. And in between is the user. And the user has to connect the dots. And these connections are knowledge-driven. So if you have an experienced user, he knows which dots he has to connect. But it's an experience-driven process. And what I suppose to use like a categorization system. This looks like a mess, but I will show you it isn't a mess. So first of all, you're tunneling all the connections through a tunnel, through a categorization system. Additive manufacturing levels, like I call it. And if you're tightening these messy connections and say, tighten everything, you get knowledge, because now you have like a categorization, level 1 additive manufacturing, for instance, for use on board. And if you're thinking about the future, this is also knowledge, because if you're thinking about the future, you have future use cases, then you look out, oh, this is similar to level 1 additive manufacturing use case I had some weeks ago. And if you're thinking now about new processes, you can also look in which category you're using this machine, for instance, and which benefits you get from this. Looking from another perspective, additive manufacturing level categorization system, it's looking like a pyramid. In the horizontal axis, you got the dissemination. How many printers do you have in your company, in your organization, in the military, for me? On the vertical axis, you get a level of complexity. So on level 1, you have, for instance, a lot of printers which are easy to use, which are really small, which do need less resources. In a table, this looks like in a really simplified way. The original table is much bigger, but for a presentation, I have the small table with me. So, for instance, for education, you got basic training in level 1. You got limited access to resources, simple equipment for the AM machines, and mostly you're doing something like prototyping, like interim parts, like I told you. And this categorization is then matched with the resources you have. So for instance, in the Navy, we have small ships and small boats. We are using level 1 additive manufacturing. If we are looking into bigger systems, we have more resources. So we can also sometimes use level 2 additive manufacturing, and so on and so on. But I don't want to bore you with all the theories. I have also some real-world examples. So this example we built on a Corvette. This is from the gray water system. Gray water system is like a washing basin, and where the water is going. This is the gray water system, and whereas one part, this is one part which is included is this whole blue assembly. And in this whole blue assembly is this black puppet valve. And the problem is that this puppet valve, for instance, it breaks in this area. The main problem is that the lowest logistical accessible unit is the whole assembly. So we have a lot of these blue assemblies laying around, but missing the puppet valve. And we used additive manufacturing for producing our interim part wear. But it's also be useful for something, not a part in instance, but it's like a intermediate repair. In this case, we had to remove the heat exchanger from the seawater cooling system. And you see seawater cooling system, these are tubes with this size. So there's coming a lot of water in it if you don't shutting the shut valve tightly. And in this case, this shut valve didn't hold tight. So we got more than 180 liters water per day into our ship. And getting water into a ship is not the best thing you can imagine, I hope. And we used additive manufacturing for producing this blind flange. I know additive manufacturing is not the best process for getting this blind flange process this blind flange. But it was the only technology I had with me to keep our ship driving. Another case for additive manufacturing is also obsolescence. So in this kind electronics, I think we are as old as me, a little bit younger could be, and we're still using it. The original equipment manufacturer, he didn't have this in storage anymore, but we wanted to use the electronics even longer. And the problem is not with the electronics, works quite fine. The problem is with the holder of the electronics cards. It's in this purple color. It's ABS. After 10 years, it's get brittle. It's no big deal. But if you're missing the spare part, you can't use it anymore. And we used also additive manufacturing here, 3D printing level 1, for making an interim parts. And we heard it also in a presentation before. Everyone is talking about metal parts. But in my research, I found over 153 use cases for additive manufacturing in the maritime sector in a short time of, I think, was a little bit more than 7 months. It's just small plastic parts. It's parts like these. Plastic parts that do mean a lot to the overall readiness level of the ship. If you have a small plastic part like this fan, which is attached to an electric motor, and this electric motor is attached to the fire extinguishing system, and you just have 4 of these fire extinguishing systems on board, and you're missing one, you're losing 25% of your fire extinguishing capacity. And that's because of the small plastic part. So it's not a sexy AM part like a brake caliper from Bugatti. It's just like these parts that make a difference, and they are not sexy. A use case for level 2 additive manufacturing is also this case where we printed a seawater filter. And the main problem with the original part was the housing is made out of metal. The filter is made out of metal. And we have a lot of seawater. Something has to corrode. I'm really lucky that the designer thought, okay, it should not be the casing, it should be the filter. So, because repairing would be a mess. But what we did, we used additive manufacturing to produce a seawater filter made out of nylon, which is also really has a big impact strength. So when we have shells, we have stones in this filter, just using a small hammer, smashing all the bits out of the filter and use it again. If you have a corroded metal seawater filter, taking the hammer, the most problems could be that you have hole sizes from this size and it's not a filter anymore. So I have one last use case. In this use case, we're on a bridge on an operating console. The problem is with this retaining ring for the track wall. These small hooks I showed are breaking really easily. And the problem is that we just can't get the whole equipment with the electronics, like around about 6,000 euros, something like that. But we just need this small ring, not the whole equipment. So what we did a redesign of the ring. And after some redesigning and some CAD, reproduced these parts. Just took around about half an hour per ring. Afterwards, some post-processing, removing the support. Could be water soluble, but we used just the pliers. And after some fitting, works quite fine. So this time, with these rings, we can support a lot of ships with this kind of solution. So we don't need to order the whole electronics. And you see this ring is in red color, it's not in black. Why did this ring break? These rings, or the small hooks from the rings break because the operator sometimes gets bored. And then he starts untightening, tightening, untightening, tightening, and sometimes this hook breaks. Happens. But now the operator is marked with a red ring, and this is called the red ring of shame. So we have also an educational effect on the soldiers. So thank you very much. This is everything for the use cases. I think I'm good in time, so I will just show you something also for the lessons learned. So we had a lot of problem like layer shifts, some materials not where it should be, some alignment didn't fit. We had also some filament salad on a frigate. So also we had a lot of things to learn. So what are our lessons learned? So first of all, you need a comprehensive strategy. Success in AM requires a holistic strategy. You have to do a collaboration innovation, foster a culture of collaboration and knowledge sharing to tackle complex challenges and identify innovation solutions. We have to get everyone together, not just Navy or doing their own stuff. It's also working together with the Air Force instances to get things done collaboratively, because more minds are better, more fresh minds, I will mean. And also training is vital. The most important thing, you have to invest in the education and also the personnel themselves. And one thing also you have to keep in mind is the data management, because it's a challenge, because it has to fit everyone, but it's also our opportunity at the same time, because everyone can use it and also have a benefit from this. And the most important thing also we learned in our process, don't demotivate your personnel by complicating simple things. Additive manufacturing should be easy. So fitting it in something like a big process chain is something that hurts additive manufacturing a lot, because speed gets compromised by that. So the benefits of the framework of the new ISO norm that I want to create and implement is with the interoperability and common AM practices, we can enhance the collaboration. We will streamline the workflows, quality standards, and reduce duplications and get more efficiency. And the most important thing for us, resilience. We want to have a network of additive manufacturing, of collective problem solving, to get the overall readiness from, for instance, a strike group, something like that, on a higher level. And this is also the higher goal. And we want to use the innovation and the knowledge sharing to drive the continuous the continuous improvement. So what I see in the future is when we are on a trip at sea and we have some other frigate with us, for instance, just collaborate with each other. If one has a problem, the other can be the solution, and the other one could be producing the part, for instances. And this is what gets everyone a step further. And this also completes my presentation. So thank you very much for your attention, and now I think it's the time for questions.
Thank you very much, Sasha. Yes. If anybody has any questions, I'll do my best to run the microphone out to you. Nobody has put anything on Slido from everything I can see. Or maybe you have questions you'd like to ask in private. Will you be hanging around for a little while?
Yes, I'm here till Thursday.
Nice, okay. So keep an eye out if you want to ask any questions of a more sensitive nature, maybe. Thank you very much for the presentation. Very good. Thank you. Okay, the next...